Hi everyone, welcome to part 2 of lecture 5, and in this lecture we will continue with hypergeometric distribution. So in this distribution, think we have a set of n objects and k of which are classified or labeled as success, and the remaining n minus k objects are failures. So here the success and failure is based on what you are looking for. Okay, so it can be, let's say we have white and black balls, and maybe you can say choosing black balls can be success. So, or in another example, tossing a coin, the tail getting head or tail can be success based on what you are looking for or what you are interested in. So in such a set of n objects, let's say we will sample n objects. That means we will select randomly n objects without replacement. Okay. Then if we define x as the random variable, and if this is the case, we can say that x is said to have the hypergeometric distribution. Okay. Okay, so let me draw, and to make it more concrete, let's say we have sorry. Okay, let me draw it to make it more concrete and say that we have n objects. Okay. Each box represents an object. So we have n objects. K of them, let's say this one, are classified as success, and the rest of them, this one, this one, this one, and this one, are classified as failure. Okay, these are failure. And among these objects, we will randomly choose n of them. N of them. Okay. So we define x is a random variable. That's mean I can choose 0 success, 1 success, 2 success, and 3 success, etc. Okay, so in this case, at most I can choose 2 of them, 2 successes. So if this is the case, if this is the problem, we can say that x random variable, for this example, this can take the value of 0, 1, and 2, because we have at most 2 successes. And so if this is the case, we say that the x is said to have the hypergeometric distribution. Okay. So let's say in this selection, how many different numbers the x can take. So x, the x is here represented by k, and this is the range of the k, and let's make it a little easier. So what is this one and what is this one? Okay, to make it clear, I will give you some specific example. Okay, let me create a page, the white page, and again, let's say we have some objects. Okay. So I have 10 objects. So the n, the capital N, is 10. And let's say 2 of them are the success, and which is labeled as k. The capital K is 2. And let's say n is equal to 3. And we have 8 failures. which is n minus k. So now let's check the range of the k, the small k, which is equal to x actually. The number of this, which is the random variables can take the different values, okay? So in other words, the k represent the possible values random variables can take. So let's say I can choose simply, I can choose between 0 and 2, right? Okay. Why? Because in all trials, in all 3 trials, I can choose the failures, and that's mean I can take the k will take the value of 0. Or I can choose 1 failure and 2 successes. In this case, it will be 2. The k will be 2, but it cannot be greater than 2, or it cannot be less than 0. So now let's look at these numbers, which is, let me write here what we say, the k in max max 0 or n plus k minus n and minimum kn. Okay, so let's put the numbers here and interpret this range to understand it better. Let's look at the maximum one, so which is this one, right? In based on our example, that is the minimum. What was k? K is 2 and n is 3. Okay, so that will be 2. My range will be, let's say, 2. Okay, the maximum. Why? Even if I have more trials, if the number of success is less than the number of trials, it is not possible to get a greater than number of my successes, right? So in this case, the number of trials is bigger than the number of success, but it's not possible to get 3 successes because I have only 2 successes. That's why I'm taking the minimum of the number of successes or number of successes and trials. That's why the maximum is 2. Now let's look at this one, which is the max of 0 or what was the n is 3 plus what was the k is 2 minus n is 10. So which is the max 0. Am I right? Yes, minus 5. So in this case, the max of this one is 0. So my range is between 0 and 2. So this is what we found earlier. But how we can interpret this one? Here, I'm trying to find the minimum one, right? Which will be the minimum. So in this case, what can be the minimum one? The minimum one in this case, 0, because I have some failures. But what if that was the case? Let's say I have same trial, and let's say success, and success. So let's do the same thing here for this example. In this case, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's say I have again n is 10. Okay, and the k is 8. I have 8 successes, and n is still 3. So what's that mean? Just put the numbers here again. Okay, so let me do it with different color, which is the max 0, or what is the n is 3, plus what is the k is 8, and minus 10. What will be this one? This will be max 0, 1, and the results will be 1. Why? I have only 2 failures, and I'm gonna choose 3 bugs. Okay, so let's say in the first selection I choose this one, and in the second selection I have chosen that one. In third one, I'm going to select a success for sure, right? Because I don't have any failures. So how can I interpret this one? Actually, this one focuses on or emphasizes that if the number of selection is greater than the number of failures, in that case, the minimum the minimum values, the minimum number of success will be greater than 0, and it will be the differences between the number of selection plus the number of success minus the number of objects. So that will be the minimum number. Okay, so this formulation shows this shows how this range formulation works. So as I say, this one gives us the possible range of that random variables. So how can I calculate the probability? First, let's look at the capital K select K. So what was that one? That one is the success, right? And what is that one? The number of no, it's not the number of, that is the value that X random variables can take. So that's mean, actually this shows us among that success, how many different ways, with how many different ways I can get success. And this one, what is this one? This is the failure. Okay. And this one is actually the remaining number of failures. Okay. The remaining number of failures. If the number of trials is 3, for example, and if I choose one of them, what's remained? N minus K, right? So this is the remaining failure in my selection set. And what is that one? This is the total possible way of selection. So this is simply give us the probability, okay? So if we simulate our example here, what we will do that for this one, let's say this one, it will be, what is the K? K was 2, K, and that will be 8, 8, 3 minus K divided by 10 choose 3. So this is the all possible group of 3 selection, okay? And this is the possible selection of the success. I mean here, I can choose this one first or this one first. So I have 2 different ways to select the success. And this one is selection of the failures. Okay, different ways of the selection of the failures. Because if the K is 1, how many points? Like my N is 3, right? 1, 1, 2, 3. Let's say here I have choose 1 success, and so in this case K is equal to 1. So I have 2 empty box left, right? So how many different selection I can make? I can choose this one first or this one first, right? Or in other words, if I consider this sample, this example. For the first box, I can choose any of them, right? Second one, if I choose that one, first one, the second one will be one of these boxes. So I can choose different boxes. So that's why this part shows how many different ways, with how many different ways I can choose the remaining failures. And as I say, this is the total ways of the selections. So if you say the P is equal to the K divided by N, which is the success probability. Why? Because I have K success and the total point is N, I will get this probability. The expected value will be the NP. Okay, so if you want, you can do just some algebra here to calculate that one, but I will skip that part. And the variance will be NP times 1 minus P times N minus N, the capital N minus small n divided by capital N minus 1. So this part is called the finite population correction factor. And if you remember this part is the variance of the binomial distribution. Okay. So you can again look at the shape of that distribution with different parameters. So for example, in the first distribution, we have 10 objects and we choose 5 times and half of them are success. So, and this is the shape of that distribution. Okay. So, and if we change the parameters, the shapes will be changed, and it can be any shape actually. It can be decreasing, it can be increase and decreasing, etc. So it can the shape can be different based on the chosen parameters. So please look at these parameters and understand how this changing this parameter affect the shape of that kind of distribution. So we will not cover this distribution too much in future studies, but I just want to explain it to give you some some information about such a distribution. So if you see that distribution in something, you will be familiar with this lecture. Okay. So this is the end of part 2, and we will continue with the Poisson distribution.